All right, time for some math notes, either using your math notebook like this or your math notebook like this. Maybe you're using just regular old paper, right? If you have your math workbook, that's going to be really helpful. If you don't, that's fine. Just write the notes on paper. So we're starting in our math notes table of contents, and we are working on 5 NBT B5, which is multiplying whole numbers, and we're going to be using the area model. Now, something that you're going to need, and this is going to go on my page 9. Now, something that you're going to need is some graph paper. If you don't have graph paper, there is graph paper in this notebook here. So I'm going to use the graph paper on the back of the notes here. So here is the graph paper that I am going to use. If you just happen to have graph paper at home, you can use that too. And so this is what we're going to use for right now. And you're going to open up to that graph paper. If you don't have graph paper at all, that's okay. You're going to draw out the area model to the best without the boxes. But the boxes help us to understand the concept of the area model. So one of the things that we're going to talk about too is something called the distributive property. So I have the problem 15 times 17. So for 15 times 17, the distributive property, what I do is I break apart or I decompose each of the factors. Remember, it's factor times factor. So I'm going to decompose 15 into 10 plus 5. And I'm going to multiply that times a total of 17, but I'm decomposing 17 into 10 and 7. So let's set up our area model now. So our area model is going to have a length of 10 plus 5, so a total length of 15, and we're going to multiply that times the width of 10 plus 7, or a total of 17. So the total rectangle that we make is going to have an area of 15 times 17, whatever that answer is, right? So that is our area model. We're building a rectangle with a side length of 15 and a side length of 7. So let's count out 15. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I decompose it into numbers that are going to be multiples of 10. So like 10, 20, 30, 40, 50, and then a single digit number. So this would be 10 and 15, right? So the 10s, okay, and then the 1. So I'm breaking it up by place value. So this length is going to be my 10, and then I kind of just going to draw out where that is, and then I'm going to have a length of 5. 1, 2, 3, 4, 5. So I'm adding that length of 5 for a total length of 15. So then this is kind of like where I'm going to be dropping down, so I might show where those lengths are going to be. And then on this side I have a width of 17. So I'm going to count out 10, kind of show where that 10 is. And remember, I'm adding that to the 7. So I'm counting down 7. So I have a total length of 17. And then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where these kind of line up together, right? So I should have 10 and then another 5 for another 15. 1, 2, 3, 4, 5. So I'm just drawing my rectangle here. So remember, right, if this is a length of 15 up here, then this is a length of 15 down here. So I have it broken up by 10 and 5. On this side, if this is 17 here, then this is going to be 17 here, and I have it broken up by 10 and 7. So here I have actually taken my rectangle and I've made it into what we call partial products. So what I am doing is I am breaking it apart and breaking it into 4 parts. So then I'm going to have 4 different multiplication problems because I have 4 different rectangles. So this first rectangle, which is actually a square, is a 10 by 10 rectangle. So how many squares in my grid graph paper are covered in my 10 by 10 rectangle? Well, an easy way to do it instead of counting them all, but you're welcome to count them all, you'll get 100 because this would be a length of 10 by a width of 10, or a 10 by 10 rectangle, so I have a total of 100 squares. So that's why when we're talking about area, right, it's square units, so I have 100 square units here, or 100 squares, right? So in my next rectangle, in this rectangle, I know that up here is 5, right? So I know that my width is 5, but I have to think about, you know, how long is this? So this right here would be 10, since this is 10. And if you count it, you'll count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just the definition of a rectangle. If this side length is 10, then this side length is 10. So then this would be a 10 by 5 rectangle, which is a total of 50 square units, which again, we can count them out and double check that we have 50, or we can just do 10 times 5. Okay, so far what I have is in my partial products, if I'm doing 15 times 17, right, I've done part of this. So I've done the 10 times the 10, which is 100. And I've done the 5 times the 10, which is 50. So up here, I have multiplied these 10s and then this 5 times 10. So eventually you'll learn something called the FOIL method. So first, outside, inside, last. So far I've done the 2 firsts, and then 2 firsts, and then the inside. Okay, and then we have this rectangle, which is a 10 by 7 rectangle, and we are welcome to count it all out, but we're going to find that we have 70 square units inside of that rectangle. And I still have one rectangle left. Now this rectangle is usually the hardest for students to figure out what the lengths should be. So this one up here is 5, which means that this right here would be 5. And then this one right here is 7, so that means that this one right here is also 7. And so this is a 5 by 7 rectangle, which is 35. So now I've done the 10 by the 7, so the 2 outside ones, and then the last 2, 5 by 7. Okay, so I've done the 10 by 7, and then I've done the 5 by 7. So 0, 0, 0, 5. 30 and 70 is 100, and plus 50 would be 150, so this needs to go in the hundreds column, and then I would have 255. So if I count up all of these, this would be 100 units, plus 50 units is 150, plus another 70 would be 220, plus 35 would be 255 square units, right? So this is our distributive property right here, and then we have our partial products. So what is partial products? Well, partial products is using we have our 5 by 7. We have our, that's this 5 by 7. We have our 10 by 7, so this one 10 by 7, which is 70. We have our 5 by 10, which is 50, and then we have the 10 by 10. So each of these pieces are multiplied times each other. So I multiply the 5 times each of these and the 10 by each of these. So that's the distributive property. So it's in parts, right? That part or that partial product where, so it's a little bit not as clear here, right, as it is here. So that's why we're going to zoom in and use this one, because this is a lot easier to understand. So we can apply this to our other questions here. So opening up our workbook, or just opening up our notebook, we're going to lesson 5, problem set, which is in Module 2, page 25. So remember, we have to go to Module 2 part, page 25. And we're going to set this up using the distributive property first, and then I want you to get rid of this. We're going to be doing partial products. So the distributive property is where we break this into 30. So we're breaking it into place value, plus 4 times 20 plus 1. And then we're going to use that to make our rectangle. So our rectangle is going to have 4 parts. And remember in the one where we actually used the grid, notice that they're not all the same size. We have one a lot larger than the other. So we should probably do that as well here, where they're clearly not the same size rectangles. So this length is going to be our 30 plus 5, or sorry, 30 plus 4. So here's 30 plus 4. And then over here we have 20 plus 1. So this one is a 30 by 20 rectangle. So this is a 30 by 20 rectangle. And then I'm going to have 30 times 20. Well, I know that 3 times 2 is 6, and then I have 1, 2 zeros for 600 square units. Okay, so then my next one, right, this is going to be a length of 4, and then this is 20, because this is 20, this is 20, right? So then this rectangle is a 4 by 20 rectangle. So we have our 4 by 20 rectangle, and I know that 4 times 2 is 8, and then I add a 0 for 80. And this is really nice because it's just the number 1, super easy to multiply by. So again, I have to know that this is, since this is 30, this is also going to be 30, and this is a 30 by 1 rectangle. Since this is 30 and this is 1, it's a 30 by 1 rectangle, which is just 30, right? Anything times 1 is just itself. So then we have this last one over here. And I have to figure out what are the side lengths. Well, what is the side length of this? It's going to be the same as this, which is 4. What is the side length of this? It's the same as this, which is 1. So this is a 4 by 1, or a 4. So then 680 is 680. 30 plus 4 is 34, right? 0 and 4 is 4. 80 and 30 is 110, and 100 and that is 714. So now we're going to quickly think partial products. I have the 1 times the 4 is 4. I have the 1 times the 30, so this row right here, which is 30. I have the 20 times the 4. So the 20 times the 4, which is this part of this row, is 80. And then I have the 20 times the 30, 20 times the 30, so this one right here, which would be 600. And then all added together, we get 714.